Hello everyone, welcome back to Math 1314, more on math. Today we're looking at Chapter 4, Section 6, Solutions. Alright, let's look at the first one. For the function x squared plus 4x minus 12, solve the following. In other words, take the function, set it equal to 0. So it's x squared plus 4x minus 12 is equal to 0. So that means we've got to factor it out. So x and x go there. The second sign is a negative, so one answer is going to be positive, one answer is negative. What times what is 12? When you subtract them, you get 4. 12 times 1, but when you subtract them, you get 11. 6 times 2 is 12, and when you subtract them, you get 4. So the answer is 6 and 2. And the 6 goes where the pluses. So now you take both of those factors, set them equal to 0, and solve for x. Those are my solutions. So my solution is negative 6 and 2. Alright, I use this polynomial function, and now I'm solving for inequality. So I have f of x is greater than or equal to 0. F of x is x squared plus 2x minus 8 is greater than 0. I factor these out. So I have x and x. It's a negative, so it's one's plus, one's minus. What times what is 8? When I subtract them, I get 2, and the bigger number gets the plus. So it's 4 and 2. Set them equal to 0, because these are my X-Intercepts, at negative 4 and 2. And at negative 4. We know that the y-intercept is negative 8. We know since degree equals 2, it's a parabola. Either opens up or opens down. Since the leading coefficient is a positive 1, it opens up. So we know the graph will look like this. So select the correct choice and fill in the answers. The solution is negative 4 and 2. No, those are my X-intercepts. Because I have inequality, I'm only looking at what part of the graph is greater than 0. In other words, above the x-axis, and it's equal to. So we're looking at these two parts, including the zeros. Because it says it has to be greater than 0. Has to be greater than 0 is above the x-axis. So the solution set is from negative infinity to negative 4 union 2 positive infinity. So from negative infinity to negative 4, it's greater than or equal to 0. And then from 2 to positive infinity. So there's my answer. Remember, if that equal sign wasn't there, we'd have parentheses at the negative 4 and 2. For the function x minus 5 over x 9, g of x is greater than 0. So we have our function x minus 5, x minus 9 is greater than 0. So let's see what we have here. First, to solve this type, for the x-intercepts, we take the top, set it equal to 0. So x is equal to positive 5. That's our first point. And then the vertical asymptote. Take the bottom and set it equal to 0. So x is equal to positive 9. So at positive 5, 6, 7, 8, 9, I have another intercept. So we have an asymptote at 9. Remember, the vertical asymptote set the bottom equal to 0. And since the leading terms are the same amount, x over x, since n equals m, the horizontal asymptote is the coefficients, which is 1. So at 1, we have a horizontal asymptote. Because it's basically 1 over x, we have this graph. And it has to cross through that 5. So there's our graph. We're looking, where's the graph above 0? So here's the x-axis. This is where it's 0. Here's one part, and all this. So the solution set is from negative infinity to positive 5. I cannot use it because it has to be strictly greater than 0. And from 9 to infinity. So I'm sorry, this should have gone up here. A related function is graphed. Solve the inequality. So we have that. We have negative x cubed minus 2x squared is greater than negative 11x. It's a polynomial. So I have to have a 0 on one side. Alright. The leading coefficient is negative. That's why it's a downward equation. But I have to get everything to one side. I can move this over there, or I can move all of this to that side. Let's see what happens. Since this is negative, I'm going to move these guys over here. And then I add 2x also, or 2x squared. So both of those cancel. And now I have x cubed plus 2x squared minus 11x minus 12. So that's my polynomial. So it's a cubic function. Since now our coefficient is positive, it looks like this. Which means I have to flip this graph. That's 2. I gotta flip it across the x-axis. So since this equation is less than 0, I want everything below the x-axis, which is negative infinity all the way to this one, which is 2, 4. And since it's not no equals, I can't use that. And I'm also here. From negative 1, each of these are by 2. Goes 2, 4, 6, 8, 10. So from this one, which is negative 1, I go all the way to this intercept, which is 3. And that's my solution. So my solution set is from negative infinity to negative 4. It's right there. Unioned with negative 1 to positive 3. So when you have this thing, you can move it however you want to, but see the final graph, it's positive, so let's flip it. We have to factor the bottom, which is x squared, 4 is 2 squared, so we have 7x over x plus 2, x minus 2. It's a difference of 2 squares. Is greater than or equal to 0. In other words, we only want everything that's above the x-axis. Since there's more x's on the bottom than the top, our horizontal asymptote is the x-axis, is y equals 0. Our vertical asymptotes set the bottom equals 0, so it's at negative 2 and positive 2. Check. And so there's a graph. So I only want the answers, since it's greater than or equal to 0, I only want the answers above the x-axis. So from here, from this, remember, this is negative 2 to 2. So from negative 2 to 0, it's equal to, so I can include that point. And then this is the second one. From 2, since it never crosses the x-axis, it's always above 0. It's that one. Solve the inequality. Since the degree of both of these are 1, if we add them we get 2. So the degree is 2, so we have a parabola equal to that or that. Since all the coefficients are positive, the graph looks like this. Set these equal to 0. X minus 1 equals 0. X plus 3 equals 0. So I get x equals 1 and x equals negative 3. So these are my intercepts. Remember, it opens up, so the graph will look something like this. And the function what's below 0. Since it's less than 0, I only want what's below 0. And it's no equality. So whatever's below 0 starts at -3 and goes all the way to 1. There. Number 7. List the critical values of the related function. Okay, critical values, remember, are the x's, that 1. The top is equal to 0, and the bottom equals 0. So these are my intercepts. These are my vertical asymptotes. Those are my critical values, because those are the values on the x-axis. So if I look at this equation, the only x I have, x plus 1 set it equals 0, so at -1. Since it's on the bottom, that's my vertical asymptote. The graph of this function is 1 over x, so the graph looks like this. And since the bottom's bigger, with horizontal asymptote is the x-axis. So the critical values are simply at x equals -1. So that's the only intercept I have. That's the only critical value I have, because that defines my vertical asymptote. My solution set, I want everything greater than 0. I want everything above the x-axis. This is below the x-axis, so I can't use that. This one, everything is above, so it starts at 0. Alright, I'm sorry. It starts at -1. And it goes to infinity. Because remember, our vertical asymptote's at -1, so the graph goes from -1 to positive infinity. Alright, same thing. Critical values, since it's 0, has to be 0 on one side. Greater than or equal to. So, take the top set equals 0, we get 0. So we cross at the origin. That's my x-intercept. And the bottom, set that equals 0. X equals 7. That's my vertical asymptote. So my critical values here are at 0 and 7. The solution set is at 0, and we have a vertical asymptote at 7. So this looks like 1 over x. The graph looks like this. But the horizontal asymptote, we only look at the leading terms. Since both of those cancel, the line y equals 4 is, so it goes over 7, up 4. This is my vertical asymptote. A horizontal asymptote is positive 4. So I want everything greater than or equal to 0. So that's everything on this side, and only that part. We have to find out what that value is. So yes, it crosses at that point. So it's from negative infinity all the way up to positive 7. We cannot use 7. And from 7 all the way up to positive infinity. Now we can't use 7 because that's since our bottom equals 0. So those are my solutions. X equals 0. I forgot about that. So at 0, there's our graph. So it has to cross the x-axis at 0. So this is at 0. That's our x-intercept. So our graph, we have a vertical asymptote at 7. We have a horizontal asymptote at 4. So the graph looks like this. And we have an x-intercept at 0. So the graph has to cross through that. So it's above the x-axis from negative infinity to 0 and from 7 to positive infinity. One more. Now we have a number over here. Remember, it has to be 0 on one side. So the first thing we have to do, we have to move this, make it a 0. So we have to subtract 3 from both sides. So we have x plus 3, x minus 6, minus 3 is greater than or equal to 0. This is 3 over 1. So the LCD is x minus 6. So I've got to multiply x minus 6 on top and bottom. So x plus 3 over x minus 6 minus 3 x minus 6 over x minus 6. Since I have a common denominator, I just worry about the top. X plus 3 minus 3 x minus 6. This has to be greater than or equal to 0. We're still setting up the equation here. So we get rid of the parentheses on top. X plus 3. Distribute this one. Negative 3 times x is negative 3x. Negative times negative is positive. 3 times 6 is 18. All over x minus 6. I don't need the first parenthesis since there's no coefficient. Combine like terms. Negative 3 plus 1. So it's negative 2x. Positive 18, positive 3, positive 21. So now we have our equation we can look at. Our critical values, take the top equals 0, so we have negative 2x plus 21. I'll just add 2x to both sides to get rid of that negative sign. So 21 equals 2x divided by 2, so x equals 21 over 2, which is 10 and 1/2. And I take the bottom set equals 0. X minus 6 equals 0. So x equals 6. That's my vertical asymptote. This is my 0, my x-intercept. And remember, let me plot those. So at positive 6, 1, 2, 3, 4, 5, 6, I have a vertical asymptote. And I have a 0, 7, 8, 9, 10, 11, at 10 or 21 over 2. Horizontal asymptote. Since they're both x's, since I have negative 2x plus 21 over x minus 6, I get rid of everything except the leading terms. Since they're both the same degree, my horizontal asymptote is negative 2. So I have to drop down to negative 2. So there's my horizontal asymptote. So it's basically the same as 1 over x. So my top part has to cross through that one, and the bottom. This is the x-axis, this is the y-axis. This is our shifted down version. And I want only what's greater than or equal to 0. Here's 0. I want everything that's above it. So all of this is below the x-axis. I can't use any of it. This is my x-intercept. So I'd go from everywhere from 6 to 10.5, or 21 over 2. From 6 to 21 over 2. All right. So those are my solutions. My critical values are at 6 and 21 over 2. My solution interval. So the critical values are at 6, 21 over 2, and the solution set is from 6 to 21 over 2. And since that's my intercept, I can include that. Alright, good luck everybody. I hope that helped.